Hello everyone, I am Sonu Sangwan. Today we are going to learn some topics of control system engineering. These topics will help you in your Polytechnic and B.tech exams. Let's start. Our first topic is Routh stability criterion. Routh stability criterion is used to find out stable and unstable system. Any equation or any system is stable or unstable, we can find out by using Routh stability criterion. It is proposed by Edward John Routh in 1876 for stability of linear time invariant system in control system. Routh stability criterion is based on arranging the coefficient of characteristic equation into an array called Routh array. We have a general equation Qs. Qs is equal to a naught s power n plus a1 s power n minus 1 plus a2 s power n minus 2 plus so on a n minus 1 into s plus a n is equal to 0. This is our general equation. Let's solve this equation. First of all, write this equation into array. Write power of s on the left hand side, s power n minus 1, s power n minus 2, s power n minus 3, s power n minus 4 and so on, s power 0. Now write the coefficients a0, a1, a2, a3, a4, a5, a6, a7 and so on. So we wrote the coefficient of this equation in row 1 and row 2. Now by using row 1 and row 2, we can find out the coefficient of row 3, b1, b2, b3. And by using row 2 and row 3, we can find out the coefficient of row 4. It means c1, c2, c3. And by using row 3 and row 4, we can find out the coefficient of row 5. It means d1, d2, d3 and so on. So let's start. We have to find out b1. b1 is equal to minus 1 upon a1 and determinant of a0, a1, a2, a3. We can write it as b1 is equal to a1, a2 minus a0, a3 upon में a1. How it will become? It will become as when we solve this determinant, we can solve it as a0, a3 minus a1, a2. But when we multiply it with minus 1, and it will change the sign and it will become b1 is equal to a1, a2 minus a0, a3 upon a1. It is the formula to find out b1. Now we will find out b2. We can write it as b2 is equal to minus 1 upon a1 minus 1 upon a1 and determinant of a0, a1, a4, a5. Determinant of a0, a1 and a4, a5. It means b2 is equal to a1, a4 minus a0, a5 upon में a1. It is the formula to find out b2. And so on we can find out b3, b4. Now to find out c1, we can write it as minus 1 upon b1 determinant of A1, B1, A3, B2. Now we can write it as C1 is equal to B1 A3 minus A1 B2 upon B1. It is the formula to find out C1. Now we can find out C2. C2 is equal to minus 1 upon B1, determinant of A1 B1 A5 B3. It means C2 is equal to B1 A5 B1 A5 minus A1 B3 minus A1 B3 upon my B1. It is the formula of C2. We can find out C2 by using this formula. And now to find out D1, minus 1 upon C1 into my determinant of B1 C1 B2 C2. So now we can calculate from here. D1 is equal to B1 D1 is equal to C1 B1 C1 B1 minus B1 C2 B1 C2 upon C1. These are the formulas to find out the coefficient of other rows. And now we can also find out D2, D3, E1, E2, E3 and so on. What is the general statement for stability or instability of system, any system? If a system is stable, then there are some conditions. For a system to be stable, it is necessary that each term of first column of Routh array must be positive and if A not greater than 0. It means the first column, column 1, column 2, column 3, column 4 and so on. The first column of Routh array must be positive. All the sign should be positive. If column 1 is positive, first column is positive, then it will be the stable system. And if this condition is not satisfied, the system is unstable and the number of sign changes in the first column corresponds to the number of roots of characteristic equation in the right half of S plane. So by using these formulas, we can find out any equation or any system stable or unstable. Thanks. Have a nice day.